Hi, my name is Yusuf Arsum, and today I will solve a centripetal force problem. This problem states that a 0.5 meter string is causing a ball with a mass of 2 kilograms to rotate in a circle on a frictionless table with a constant velocity of 5 meters per second, tracing out a perfect circle. And we are supposed to determine the centripetal force acting on the ball. First, I will define what is a centripetal force. A centripetal force is a force directed towards the center of the circle. In this situation, um, the centripetal force is tension because the rope is tied to the mass and pulling it. So it's tension. Okay. In addition to a centripetal force acting on the ball, there's also a force of gravity pulling it downward and an upward normal force. In order to determine the force of tension, which is a centripetal force, I would first draw a diagram containing all the forces acting on the mass. Okay, so we'll draw that really quickly. So there's a ball, there's a string, and it's going in a circle. So as we said, there is a force of gravity pulling it downward, normal force upward, and then a tension pulling it towards the center of the circle. So then we use Newton's second law for the horizontal direction because the force of tension is on the horizontal plane. We first convert A to centripetal acceleration, and then F to centripetal force. Um, as we know, the centripetal acceleration formula is v squared over r, which is this one right here. So we plug that into the centripetal acceleration and make it equal to the force of tension over the mass. So the force that we're going to use is only the horizontal one, and the only horizontal force acting on the ball is tension. So then we're going to solve for f of t, which makes it m times v squared over r. So then we're going to plug in the numbers that are given. So f of t equals mass, which is 2 times v, which is 5 squared over r, which is 0.5. Alright, and your answer will be 100 newtons. And that's pretty much it. Thank you and have a nice day.